welcome back now. You had a little assignment to do the last time. I'm going to reiterate this again and again each lesson. Even though you're submitting a form on the Teams network there, you still need to copy down these and keep a copy so that when we review the assignment that you did from the last time, that you have something you can go over and know how you did. Because I know on the forms you cannot bring that back once you submit it. So please be true to yourself and make sure you make an extra copy of your work and your answers. And we're going to go through this very quickly because this is a pretty complex lesson. We're going to go over it now. We'll go ahead over it again next week before we quiz on any of this. And then, of course, the new lesson today should be a little easier to pick up than what we're doing here. But let's go ahead and look at this. In the last time when we're dividing, and I've written them all down on your lesson assignment, it has it shown like this, divided by, and then that's up there. But you should always transfer it to the fraction form, just like I told you before. Instead of using the divided by, put your denominator underneath, and then we can use the rules for taking care of simplifying exponential values as well as the coefficient number in each one. Here we know that we can simplify the 56 and the 4 by dividing by 4. That's going to leave us 1 at the bottom. 4 into 4 is 1. Do we need the 1 when it appears with other variables? No. So we don't have to put the 1. If you put the 1, that's fine. I don't have a problem, but it's not necessary. And then we know if you did that correctly, 4 into 56, I believe, goes 14 times, does it not? All right, now let's take a look at this here. All right. Let's see. All right, so now, s squared can simplify with s squared, and it means 1, right? It just cancels out. Do we need a 1 over a 1? No. All right, how about this? We have t divided into t to the cubed. So that is t to the first. Do you remember the process? We should subtract, correct? Just like when we multiply, we add. Now, when we divide, we subtract. That was the rule we covered. So be sure that you know that rule. T1 from T3 is t squared, and then that would be 14t squared over 1. Now, let me ask you this. In fraction form, do we need a 1 on the bottom? No, we do not. And there's your answer. Now, we can do much the same here. Let's look at this one. Remember that 48a cubed bc to the 5th was divided by this, so you want to put it in fraction form. I hope you did. Makes it easier. 12 into 12 once. No 1 is necessary. All right. 12 into 48 is what? That's correct, 4. Now, remember, you have a to the 5th divided into a to the 3rd. Remember, we're subtracting this one from this one. So it would appear 3 minus 5, right? But we keep the answer down on the bottom. All right, so we still want to subtract 5 minus 3, but since this is bigger on the bottom, we leave the answer down here, not up here. The a to the 5th is bigger than a to the 3rd. We still subtract, but we leave it in its place where the bigger one is. Now, is that true for this next one, b? b cubed, is it bigger than b to the 1st? Absolutely. So 3 minus 1 is what? So that would be b to the what? Squared. Pretty simple. I'm just reteaching you this. And so if you submitted a different answer, let's go back and correct it. All right, now, c squared, c to the 5th. We still subtract, right? But which side has the bigger? The top. So let's leave the remainder up here and make it c to the what? 3rd. And that's what my answer shows. 4c cubed over a squared b squared. All right? We have a few more of these to do, so I'm going to do them quickly. Watch this. Negative 15, positive 25. Divide that by 5, and what do you get? You get negative 3. Divide that into that, and you get 5. Can we go any further and simplify? No. All right. A to the first from a to the, x to the first, x squared. This is larger. 2 minus 1 is x. We don't need the 1 up there. This is larger than the y to the first, so 2 minus 1 is what? Y. So if you did it that way, it's acceptable, but we do not need that. Let's continue on. All right. If you struggled with this one, it's pretty easy. Look at the numbers. What number goes into 8 and 12? 4, right? So let's do that. 8 into 12, or 4 into 12 is 3. 4 into 8 is 2. Okay, m squared and m squared will cancel out. And then n squared, n cubed, which is larger? 3 minus 2 is what? N to the first, or n. All right, don't forget that. Now, about this time, you're probably saying, we got 5/3, and we have, and of course that's a negative, and we have 3/2. Why aren't you changing improper fractions in this algebraic problem? Because when we do that, when you switch over to algebra, you'll find that when I'm getting the answers here, algebra in fraction form, I do not want you to change back to the proper mixed number. Because some of you may have put this, and that gets a little bit confusing. Some of you may have put, for this one here, 1 2/3, and then that would be x over y. That gets a little confusing. We want to leave them always in their improper fraction. So I'll keep reiterating that over and over again. All right, negative 17 into negative 51 is 3. C to the 5th minus c to the first is, and that stays on the bottom, doesn't it? C to the 4th, remember, bigger? Okay, this one stays on the bottom, so that's going to be 4 from 3 is D. I hope it's getting a little simpler the more we do those. So we've done 5 of those problems where we have a monomial into a monomial. Now, you remember that in this one you had all of that. You have this complete trinomial divided by s squared t. All right, now, I went ahead, if I'm going to do this properly, I'm going to divide this into that. I'm also going to divide s squared t into the second one, and s squared t into the third one. So now that means I'm going to have an answer for each one. All right, since these are all positives into positives, my operational signs are not going to change, are they? All right, so let's see here. We have a 2, right? All righty. Let me move it down just a little bit. 2, all right. Do we have an r on the bottom? No, we have to leave the r here, squared, okay? And let's see, we have an s squared. Look at that, s squared, that cancels out. We have a t into a t, so our answer is 2r squared for dividing that. Now let's try this one. Do we have a number here? We leave the 2. All right, how about an s squared into an s cubed? That's on top, so that's going to have to be s. How about a t single to a t to the squared? 2 minus 1 is t. Is there anything left on the bottom? No, everything's canceled out on the bottom, so we don't even have a denominator there. Now let's try the last one. Is there an r on the bottom? Nope. So we want to put the r. Is there an s squared? And how does that divide? What's left at the top? S squared. All right, how about a t1 into t to the cubed? what's going to be left there? T cubed. So your answer is a trinomial 2r squared plus 2st plus rs squared t cubed. And that's by simply taking each part of the step one by one. Binomial divided by this. So we're going to divide this into that. We're also going to divide the same into the second part. Let's do this one. Ready? Those cancel out. The a is left. We have an x to the first under x to the cube. So what's left? 3 minus 1, x to the squared. So nothing is left there. We have an a, x squared. All right, now, the operational sign becomes a plus right there. 2 into 4 goes what? 2. All right, is there a b up here? There's no b down here, so it stays the same. Now, what happens here? X and x cancel out. Is there anything else left to do? I don't think so. Trinomial. All right, we're going to do each one. Now, before I start to give you your answer, look, we have a plus here, and what do we have over here? Positive into negative is a minus. So now we can begin. 8 into 2, 4. U into U, cancels. V into V, cancels. We're left with a 4. 2 into 10 goes what? 5. U into U, cancels. V into V squared leaves a V to the first. Now the minus, oh, and the W, I forgot about that. There's a W left there too on the top. So everything cancels out there. 2 into negative 8 is negative 4. U into U, V into V. What's left on the top? W. 2 more to go, and let's see how we do. All right? 2x to the y, 2xy. All right, now I'm running out of room, aren't I? So let me see if I can come up here. All right, hopefully this is not too confusing. All right, let's go ahead and do this one here. 2 into 2. That's going to be 2. X into x, y into y. What should I put next to the 2? You're right, the z. All right, what's the operational sign? There? Okay. Now let's try the next one. 2 into 12. X into x disappears. Y into y disappears. What's left? What goes next to the 6? Z squared. All right, one more. Uh-oh, operational sign is different, isn't it? Minus. Okay, 2 into 6, 3. X into x. Okay, that's going to give me just a simple y. We have one more part, don't we? This is a quadrinomial. We have the 2xy. Okay, 2 into that. It's going to be 6. X into x cubed will be x squared. And y into y is cancels out. And z is left. So, now, the next time we go over this, if you're going over this at your seat, get on chat the next bell time that we have and get with me. We can walk through these. These are very difficult, I know, but they are part of the algebra that you will be having when you take Algebra 1, and I want to get you ready for that. Last one here before today's lesson. Okay, 5 into 5, that's 1, right? A into A, and then x into x squared. The only thing we have left is an x, isn't it? The 5 disappeared, the a's disappeared, the x squared over x. Now, we have the operational sign there. 5 into 15 is 3. A into a cubed is a squared. And x into x disappears. So there's the final one. like I said, be in touch with me if some of these get pretty tricky. We good? That's all I have on that part. That's really a long review of the assignment that you did, and I apologize for that. But I think we bared through that pretty good. Now that brings us to today's lesson, which should be a little bit easier. Okay? We're going to go back to multiplying. Remember, we multiplied monomials times monomials, monomials times binomials, and monomials times trinomials. Now, if you remember in those, you only had to multiply the outside times each part of the inside. Now, we have a little problem here. I put down several problems, if you will, on paper, if you're watching me. Let's go ahead and write these problems down. Go ahead, I'll pause for a moment, write these down as you see them, focus in on them. I've already done number 1 example. We're going to go through 2, 3, 4, 5, and 6 in a moment. All right, now that you've gotten those all written down, let's take a look at the process. Anytime you multiply algebraic terms, everything must be included. So here we have 2 parts, here we have 2 parts. All combinations must be put together. We call it the FOIL method. It's really kind of a fun way to figure it out. It's an easy way to follow. It says you want to multiply the first terms, see, 4n and 5n are the first terms of each binomial. Then secondly, you want to multiply the outside ones. The 4n is outside, the negative 8 is outside. Then the third thing you want to do is multiply the inside. The 4 and the 5n are the inside terms. And then finally, the last part is the last terms, where you have the 4, the last term on this one, times the minus 8 on this one. Now, let's see how I did this in picture form. 4n times 5n, 4 times 4 is 20, n times n is n squared, correct? All right, now, we're going to do the outside. Look here, 4n times minus 8. 4 times 8 is 32. Since it's a negative 8 or minus 8, it has to be a negative. And then n stays the same. Oh, you'll see something interesting here. We have another n term show up. The inside one's 4 times 5, a plus is plus 20 with an n. So don't forget this. It looks like we have 2 terms that we can combine. And then finally, we have the 4 times negative 8, negative 32. So, if you remember, in algebra, can we add like terms? Can we? Of course. And n plus an n would be like terms. See? So the 5th step is always look to the middle and see if the O and the I parts are like terms. And they are. So negative 32 plus 20 has to give us what? It has to give us a negative 12, doesn't it? N. So a negative 32n plus a 20n would give us negative 12n, and our answer is in the form of a trinomial. All right, I hope you understood that, because on these 5 we're going to do the same thing. Let's go ahead and take a different color. And if you'll go ahead and look at this one, what are the first terms? 5x, 5x. What's the result? 25x squared, isn't it? All right, what about the outside terms? 5x times minus 8 has to be a negative, positive times negative. 8 times 5, 40, with the x being the lone variable. All right, now we go to the inside. Look at this. Negative 2 times positive 5x is negative 10x. There we go. Good. What's that leave us? Number 4, the last. Negative times negative. Did you remember the integer rule? Positive. 2 times 8, 16. Now, don't forget, are there 2 like terms to put together? I do. I see them right here. You have a minus 40x and a minus 10x. If you combine the two, a minus 40 with a minus 10, you are going to get 25x squared minus 50x plus 16. All right? And that's what happens there. Why don't you go ahead and take a moment and do the next one. Put it on pause. You have this written down, 6x plus 2 times 2x plus 8. Go ahead and use your first outside, inside, last FOIL method. And take a moment and see what you've caught so far on this. Okay, now that you've come back, let's see what we did. First, that's right, 6x times 2x is 12x squared. Give me a black one. Okay, get my helper to get me a black pen because it's running out of ink. And there we go, thank you. All right, now what about the outside? All right, outside 6 times positive 8 is plus 48x. All right, inside is 4 plus 4x, and then the last is going to be plus 16. So we're working with all positive results. Now, can we add those two together? A 40x, 48x, and a 4x? Absolutely. So we come with 12x squared plus, what's the combination? 52x. Seems like those are pretty large numbers, aren't they? But we're working with algebra. It gets a little more complex and a little bit higher. Let's go ahead and look at these now. 3 more to go in the lesson. Go ahead and try that one. Come back and we'll continue the lesson. All right, now that you've tried that one, let's see. 3x times 1x is 3x squared. That's first. All right, outside's going to be 3x plus a positive 4x is plus 12x. The inside says plus 3 and positive 1x is plus 3x. Did you get that one? And then finally, the last is going to be 3 times 4, which is 12. Now, by now, you should have already seen, don't forget step number 5. Are there 2 to combine? Yes, there are. So now that leaves us 3x squared plus 15x plus 12. All right, now we've done 3 of those problems. Hopefully you're getting successful at doing them. Let's go ahead on your own and do those 2. Take a little time to do that, and as soon as you're done, come back online and see how you do. Now hopefully you've completed those 2 and you're back on with me. Let's go quickly on this first. 15b squared. Outside, up negative. I hope you didn't forget this was a negative value, which would be minus 30b, not plus. If you put a plus 30b, it's already in line to be wrong when you're done. So don't forget your minus times your plus. All right, what about inside? We have 2 positive. That's a plus 12b. All right, then again on the last, don't forget, negative times positive is negative 24. So already we might have had somebody put a plus 30 here and a plus 24 here instead of your integer rule. You know that's going to be automatically wrong because those 2 are not going to be the correct answer if you put a positive here. Let's see, we do have 15b squared. Now subtracting them is a minus 18b. If you put a plus there, you probably had plus 42b, wrong. And then if you put plus 24, you did not correct. So I'm trying to show you the easy mistakes that can be made. These are mistakes I make often when I get in a hurry. So the rule is don't get in a hurry. Do your steps. Last one. X times x is x squared because you have the coefficient of 1 times 1, which disappears. Okay, your outside is negative 7 times x is minus 7x. Integer rule. The inside you have negative 4x or minus 4x. Don't forget integer rule. And then finally, here's a common error. You do this times this. Don't put negative 28. Why? Because negative times negative is never negative. And you've learned that one over and over again, so it's got to be plus. Now, looking at those two on this final review problem, x squared, you have minus 7x, minus 4 more is minus 11x. If you're doing your integer rules correctly, and it finalizes with that. There we are. We've completed the lesson. Now you will have an assignment of several of these types of problems from the FOIL method. Enjoy it. If you have trouble with it, be sure to get in touch with me. We will look at the review of the assignment next time. So I wish you the best, and God bless, and see you next time.